In this video, we're looking at following on from the previous video where we converted component to polar and looking at how we convert polar back to component. So essentially, we're looking to go from this form, polar form, and convert into component form. So really what we're looking to do is use the magnitude and the direction to calculate the x and y displacements. Right. So the process is pretty simple. If we look at the top diagram, the triangle, we'll see that here is our angle and our magnitude. And if we apply simple trigonometry, because these are perpendicular, we should be able to use a sine and a cosine ratio to determine the x and y values. If we look over here at the y, we can say sine theta is equal to opposite, which is y, over the hypotenuse, which is magnitude. When we arrange that, we end up with y is equal to magnitude of a sine theta. If we do the same thing over here with the x, we get cosine of the angle is the adjacent over the hypotenuse, so x over magnitude of a. Then we end up with x is equal to magnitude of a cos theta. So it's as simple as saying that the new vector a will be, in storage vector form, x and y, which will be magnitude cos theta and then magnitude sine theta. Now if we want to write it in our standard component form, then it will be a cos theta I and a sine theta j. Okay, so that's all we need to do to convert. Essentially, we need to multiply the magnitude by the cos and the sine of the direction. So we'll look at a couple of examples. Okay, we're going to look at converting vector a, which is 5 and 30 degrees, to component form. So a will simply be 5 cos 30 and 5 sine 30, which will be 5 times root 3 on 2 and 5 times 1 on 2. So a will be 5 root 3 on 2 and then 5 on 2 in the x and y direction. Or we could write it as 5 root 3 on 2i and 5 on 2j. Okay, in the second example, we're looking to convert b is equal to magnitude of 2 with a direction of 225 degrees to component form. So b will be equal to 2 cos 225 and 2 sine 225. Now, if we're going to do this by hand, we can apply trigonometry. So in this quadrant, the acute angle remaining from the x-axis is 45 degrees, so 225 degrees around, 45 degrees more than 180 degrees. In this quadrant, both sine and cos are negative, so that means we could rewrite this as negative 2 cos 45 and negative 2 sine 45. That makes that much easier. So negative 2 multiplied by 1 on root 2, or I suppose we could use root 2 on 2, and then negative 2 multiplied by root 2 on 2. Again, these are standard triangle values, and we end up with negative root 2, negative root 2. So b is equal to negative root 2i plus negative root 2j, or negative root 2i take root 2j. Obviously, you can also put that straight into your calculator if you have your calculator available to you, and we get that same outcome. Okay, that completes the lesson on conversion from polar component form.